All right, so welcome back. We want to look at the second method. All right, we want to look at the second method of going about vector product. And like I've said, I'm going to keep this example so that we use it also for this other method so that we see the connection and we see that they're basically the same, right? Now, by the way, for your assignment or rather for your revision or sort of, in our case, in this case, we multiplied A multiplied by B. That's what we got. So in your own time, try to find the value of B multiplied by A. I want you to find that in your own time, and then you can always send me your answers so that I check them out and see if there's something that you've done wrong, or rather to prove if you're okay. All right, so we want to look at the matrix determinant method, right? Determinant method. Now, when you look at this, right, I'm sure you guys are quite used with calculating the determinant of a 2 by 2 matrix, right? Now, by the way, you can only find, unless, of course, I'm not a mathematician, right? I'm not a mathematician, but I just love these things. I love doing this, at least at my level. So far, what I know is that you can't find the determinant of a matrix which is not a square matrix, right? So a square matrix is one which has the same number of rows and the same number of columns. So such as a 1 by 1 matrix, that's a square matrix. Of course, you can't find the determinant in that case. And then we also have a 2 by 2 matrix. So I'm sure you've gotten used to a situation where you have, let's say, a matrix like A, B, C, and D, right? And then in this case, so let's say if this is our this is our matrix A, and then we say the determinant of A, right? The determinant of A, or we use these symbols, or we also say that A is simply equal to, we use the straight lines, A, B, C, D, like that, right? And then how do we calculate? We simply get the diagonal minus the minor diagonal. So we get this, the product there, and minus the product right here. Okay, so that's how we go about it. So we're going to have okay, so we're going to then have A multiplied by B, by D, so that is AD, all right? And then I want to use different colors, minus what? BC, not so, minus BC, okay, minus BC. So this is for a 2 by 2 matrix, all right? This is for a 2 by 2 matrix, right? Now, for a 3 by 3 matrix, it's a bit different and it's a bit more complicated than these others. Okay, and for purposes of this lesson, I'm not going to go so much deep. Okay, because we have to look at things like minus, and we also have to look at things like cofactors. All right, but I'm not going to explain all those details for purposes of this lesson. That is for mathematics, because this is physics, by the way. Right, so I'm going to explain, when we start looking at matrices in mathematics, I'm going to explain in much details how we get the determinant of a 3 by 3 matrix, and starting with the cofactors, we also look at the minors, and then we look at the placeholders, all right? But in this case, I'm just going to be mentioning them without really trying to get so deep into that, because it means that we're going to spend much more time, and you guys are going to be confused for purposes of this lesson. So I'm going to be mentioning them here and there and try to explain a bit about them as we proceed, but not too deep as I should in mathematics, right? So this, in a case where you have two vectors that are only in two components, for example, you're given vector A, maybe let's try to do that, right? Let's try to do that. Let's say if you have, let's say you're given vector A, all right, I'm going to just cut this same one, these same two vectors, and then I'll just end on j. So let's say A is 2i minus 3j, and then B is I plus 2j, right? And then we are trying to find the vector product, okay? Now, usually this one is going to be a bit more complicated because it's not even complicated anyway. So what we just do is we say that A multiplied by B is going to be equal to, we form a matrix, right? We form a matrix, so this is going to be, so you can get, we say 2i, and then we have minus 3j, okay, and then here we have I, and then you have 2j, okay. We form a matrix like that, not so. And then we now do the multiplication according to this. We do the multiplication according to that. So what we're going to get, we go for the major diagonal. The major diagonal, this is going to be this by that, that is going to be 2i by j, right? I by j, and then we are also going to have plus this by that, that is going to be what? Okay, that is going to be negative 3, right? Negative 3 j by I. Okay, so this is then going to be equal to, oh sorry, here this is 4, this should be 4. Okay, so then this is going to be 4, remember I by j is what? Is k, right? And then we have minus 3 here, and then j by I is what? J by I is negative k, okay? And then this is going to be equal to 4k, negative and negative, that is positive, so this is 3k, which is going to give us 7k, right? If you remember in our previous video, if I tell you able to remember, the k in the final answer, we remember that it was something like 10i, then plus 9j, and then plus 7k, if at all you remember. So this is what basically we have there. So, and this makes sense because here we just got the first two components of each vector, and then we formed vectors like that. Okay, so that is how you can get, if you have two vectors, right, which are in two components, you can simply use the matrix method like I've done there, which is very simple, okay? Which is very simple. You can either do as you are like you're expanding using the algebra method, or you can use the matrix method. It's still going to give you the same answer. All right. So let's go to a situation where we have a 3 by 3 matrix, or rather in a case of 3 by 3 matrices. Now, let me try to give you a bit of a background. I'm trying to check with my time. I don't want my video to be way beyond 20 minutes, because most of the times what happens, if it goes beyond 20 minutes, then it goes on mute, videos towards the end, like there's nothing, you can't hear anything. Okay, so let's say we have a matrix. Let's say we have a matrix A, which is, let's say we have A, B, C, D, E, F, G, H, I, right? So let's say this is our matrix, right? And then what we now need to do, we want to find the determinant of A, this matrix A, right? So now, we have what are called placeholders. Now, I'm not going to explain how we get those placeholders. Like I mentioned, I'm going to explain that in mathematics. Now, the placeholders, we're going to have, we have positive, negative, positive, then negative, positive, negative, then positive, negative, positive. So they interchange, they alternate. Positive and negative, they alternate like that, right? And then we also have, so these are what are called placeholders, okay? Placeholders. And then we have what are called cofactors. So a cofactor is simply any particular element in this matrix, okay? So these are elements, right? So any particular element together with each sign, together with each placeholder. For example, when you look at A there, if you put it together with the placeholder, then it's going to be a cofactor. All right, it's going to be a cofactor. So if we have, let's say A, okay, it's positive, but since it's positive, no need of putting that. And then if we get B, we say negative B, so this is a cofactor, just like that, right? Just like that. Now, we also have what are called minors. Minors, how do we get the minors? You get the minor when you cancel out the row and column in which a particular cofactor is located, okay? And then what remains is a 2 by 2 matrix, which is called a minor. All right. For example, if the cofactor I'm looking at is A, and then I'm going to cancel out the row and column in which A is, so I'm going to cancel out this row and that column, and then what remains is what a 2 by 2 matrix, which is called a minor. Called a minor. So I'm going to remain with that 2 by 2 matrix called the minor. So the minor of A is this matrix that I've put in green square. Okay, so that's basically some of the few concepts about these matrices. Now let's get into that before I get carried away and start explaining a lot of stuff on matrices. Okay, so let's start with A. So we want to get the determinant, right? So what you do is you can choose any particular row or any particular column which you can get where you're going to be getting your cofactors and your minors. Okay, you just get one, either a row or a minor. So in this case, or a column. So in this case, I'm going to get this particular row. Okay, so now what do we do? So this is the determinant of A is then going to be, right? I'm going to start with A. Remember, A is going with the positive there because we're saying that the placeholder for this first element here is positive. So I'm going to deliberately put positive A, okay? I know that I shouldn't put the positive there because it doesn't change anything, but for purposes of your learning, I'm going to deliberately put it there. So positive A, and then I multiply with the minor, right? Now, how do I get the minor? Like I said, you cancel out the row and the column in which this A is. So I'm going to remain with E, F, H, sorry, this should be A, B, C, D, E, F, G, H, I. This should be I. Okay, and I there, right? So I remain with a 2 by 2 matrix where I want to find the determinant. So you have to use those straight lines to show that you are getting the determinant of what is inside there. And then from there, I move on to the next, okay? So I move on to the next. So I say plus, right? And then I have B, and then I have the negative there. So remember, the placeholder for B here, B is corresponding with that. So I'm going to have negative B, right, multiplied by the minor. If I cancel out B, the row and column in which B is, so I'm going to cancel out, let me use red. I cancel out that and that. So what do I remain with? What I'm going to remain with is D here, and then I have F, I also have G, I also have I. Okay, so that's what we're going to have. And then I move on to C, right? I move on to C, so it's a plus, and then this is the placeholder which is corresponding with C is a positive, so I say plus, positive C. So I have deliberately put the positive there, okay, deliberately. So again, I'm going to cancel out the row and column in which C is located. So the row and column in which C is located is, so I'm going to cancel out the row and the column, okay, and the column. So what am I going to get? I'm going to remain with, D, E, D, E, then G, then H, like that, right? And then we can say that what we're having, those are small matrices, the 2 by 2 matrices, which we can go about the same way we get the determinant of any 2 by 2 matrix, right? So this is now going to be A multiplied by, so remember it's major diagonal minus minor diagonal, so this is EI minus HF, okay, let me say FH, like that. Then positive and negative, that is going to be negative B multiplied by, so this is DI, all right, then minus FG, okay, minus FG. Then positive and positive is positive, so plus C multiplied by DH minus EG, okay. So if we had values, would simplify further, isn't it? Would simplify this further. So, but in this case, this is going to be the answer, right? That is going to be the answer. So that is how you get the determinant of a 3 by 3 matrix in simple terms, right? Real quickly. So you do it simply like that. Now let's go into matrices, okay? Let's go into the vectors, the topic that we're looking at, right? So I'm going to erase this, and then we get the 2 vectors that we want to look at. So again, given that A is equal to AX I plus AYJ plus AZK, sorry about that, and what? B is equal to BXI plus BYJ plus BZK, okay, plus BZK. Then we say find A multiplied by B. As usual, in your free time, you should find B multiplied by A using this method. Okay, so now what we do here, all right, we form a 3 by 3 matrix. Okay, we form the 3 by 3 matrix. So in this case, the first row, okay, the first row is going to have the unit vectors I, J, and what? K. That is going to be the first row. And then the second row is going to have the coefficients of vector A. And then the third row is going to have the coefficients of what? Vector B. Okay, as simple as that. So the first row is going to have the unit vectors I, J, and K. And then the second row is going to have the coefficients of in vector A. And then the third row is going to have, or rather, the components and or rather coefficients of vector B. So what am I saying? What I'm saying is that A multiplied by B is going to be equal to, okay, so we're getting the determinant. So this is, the first row is going to have I, J, and K, all right, I, J, and K. And then the second row is going to have the coefficients in vector A. So we're going to have AX, AY, and AZ, right? And then the third row and last one is going to be to have B. So this is BX, BY, BZ, okay? BZ. So you can see that I is in the X component. So the first row should have the X component. The first column should have the X component. The second column should have the Y component. The third column should have what? The Z component. Okay. And then we go about it the same way we were calculating the determinant in the previous matrix that I'm just from explaining. So we're going to get, remember the placeholders, positive, negative, positive, negative, positive, negative, then positive, negative, positive, like that, right? So the placeholder for I is positive, so I'll deliberately put it there, and then I put the I, right? And then I'm going to cancel out the row and column in which I is. So if I cancel out the row and the column in which I is, I'm going to remain with that. Okay, so I'm going to remain with AY, AZ, BY, BZ. Okay, like that. And then I go to J, so I say plus. Now J is corresponding with a negative there, so I say negative J, right? Then I cancel out the row and column in which J is, the row and column in which J is. All right, I'm going to remain with what? AX, AZ, BX, BZ. Like that. And then I go ahead and look at K. So I say plus. So K, the placeholder for K is a positive, so I say positive K. So I've deliberately put the positive there. Then I cancel out the row and column in which K is. So I'm going to have AX, AY, and then we have BX and BY. Okay, and then I'm done. Then I go ahead and find the what? The determinants of those 2 by 2 matrices. So this is going to be I, right? I. So this is now AY by BZ. This is going to be AY, BZ, and then here we are going to have minus AZ, BY, not so. And then here, positive and negative, that is going to be negative J, right? Negative J, then AX, BZ, then we'll have minus, here we're going to have minus what? AZ, BX, and then plus K multiplied by AX, BY minus AY, BX, right? Like that. And then the only thing that we need to do here is simply to rearrange it, basically. So we know that the I should be in front there, so we're going to have what? So this is going to be equal to AY, BZ minus AZ, BY, I minus what? Minus AX, BZ minus. Now, let me show you a trick here. Let me show you something that, okay, let me maybe first continue and then I'm going to do that in the next step. Okay, minus AX, right? Minus AX, AZ, BX, then this J comes in front there, plus AX, BY, minus AY, BX, okay, K, right? Now, from there, what happens? What happens from there? Essentially, you're basically done, but you just want to try and, make this look more, look better, okay? So you don't want to leave a negative here, right? You don't want to leave the negative here. So how do you get rid of the negative? So you can swap these two, right? You can swap these two. What is inside there, you can swap them, right? So you're going to have, so like I said, you're essentially done, but you want to get rid of this negative so that, remember, in the other one, in the other method, we had the positive there, we had plus, so we're going to have AY, BZ minus AZ, BY, I, and then minus, so this is going to be negative AZ, okay, so sorry, I'm running out of space. Let me just do that real quickly, and then I try to remove one of the videos from my phone. So this is going to be AZ, so I'm starting with this one, AZ, BX, and then plus AX, okay? Now, let me just try to do this in one step. So what is going to happen is that here we're going to have plus, right? AX plus AX, BZ, right? I mean BZ, J. But then here we can factorize out the negative, okay? If we factorize out inside there, we factorize out the negative, right? What is going to happen is that this one is going to become negative and this is going to become positive. Then the negative is going to multiply with this negative outside there. So what I'm saying is that we're going to, outside here, we're going to, it's like we have minus there, and then we have negative, okay? We factorize out the negative, so I have AZBX, all right? AZBX, then minus, because we are factoring out the negative, this is going to be minus AXBZ, okay? And then we have the J there, right? And then this negative here and the negative there, which is this one, that one, they're going to cancel out so that they become positive. So let me just do that because of the space that is running out in my phone. So this is going to be plus, right? Plus, then plus AXBY minus AYBXK. Okay, so that is how you go about it. So this is quite simple. I think most students, they find this one, this method easier than the other one, right? They find it easier than the other one. As you can see, this one I've done it just on one board without erasing the board again. So let me end this video right here, and then we solve that question that we had again, and then we'll be done from there. Okay, so see you in the next video. Okay, so I've tried to explain how we get this using the determinant method. Now let's look at an example, right? Let's look at an example. Like I said, I'm going to use the same example that we had in the previous video, where we used the algebra method. So now, in this case as well, we're going to say that A multiplied by B is going to be equal to, so we want to find A multiplied by B and also the angle theta between what? A and B. That's how the question was. But like I've mentioned to you guys, everything else remains the same, okay? The only part where we can use two different methods is when getting the vector product, okay? You can either use the algebra method or you can use the determinant method like I'm going to explain right now, okay? But everything else on getting the angle between the two vectors, you do the same thing, essentially the same thing. You have to find, remember we said that A by B magnitude is equal to magnitude of A, magnitude of B, and then sine theta. So I mean that we need to find the magnitude of that product that you're going to get here, and then you get the magnitude of A and the magnitude of B, and then you work out everything else just like we did in the previous video. So now, here in this case, we just want to get A multiplied by B. So again, in the first row, you're going to have the unit vectors, which is I, J, and K. And then in the second row, you're going to have the coefficients in vector A. So this is 2, and then we have -3, and then we have 1, right? And then in the next, in the last row, you're going to have the coefficient in vector B, that is going to be 1, and then you have a 2 and a -4. All right, and then you proceed like this. So you're going to have this. You have the cofactor I. All right. So again, remember the placeholders. You have positive, negative, positive, negative, positive, negative, right? And then positive, negative, positive. Okay. So I'm deliberately put the positive here. So you have positive I. All right, and then multiplied by the minor. So you cancel out the row and the column in which I is. You're going to remain with -3, 1, 2, and -4, right? That's what you're going to remain with. And then you say plus, right? So you have this J here. You have the J there, which is going to, and then the placeholder is negative. So you're going to have -J, and then you get what? If you cancel out the row and the column in which j is, you're going to remain with 2, 1, and then 1 and negative 4. And then you go ahead to k. So this is plus. The placeholder for k is positive, so you say positive k. And then if you cancel out the row and the column in which k is, you're going to remain with 2, negative 3, 1, and 2. And then you go ahead to find now the determinants of those minors. So this is going to be equal to, this is positive, this is I, right? And then multiplied by, this is 12 minus 2, isn't it? Negative 3 by negative 4, that is 12. 2 by 1, that is 2. So minus that. And then you have, you say minus j. And then you're going to get, this is negative 8. Negative 8 minus 1. All right. Negative 8 minus 1. And then you have plus k. This is going to be 4 minus negative 4, right? I mean minus negative 3. Minus negative, okay? So minus negative 3, so that is going to be plus 3, like that. So this is now going to be equal to, this is 10i, and then this is negative 9, multiplied by the negative, that is going to be plus 9j, and then this is going to be plus 7k. Okay, so you can see that this is exactly what we got even in the when we're using the other method, exactly that. And then you proceed with everything else. Okay, this method, I think I really love this method. It's quite simple. It's easy to understand, and as long as you don't make mistakes with the signs, okay, the placeholders and the signs within the matrix itself, as long as you don't make those mistakes, then you're warm and dry. Okay, so this is exactly what we got in the previous example. So this essentially marks the end of our topic on vectors. From here, we're going to start looking at Newton's laws. And it's also a very, very interesting topic. So thank you so much for joining me in this lesson. And all those that are watching my videos, remember to click the like button and also subscribe to the channel, and also remember to share. Okay, if possible, you can also click on the reminder button so that whenever I upload another video, you can always be notified. Okay, the other videos obviously that I post, those are to do with medicine. The medical videos, I also post some medical videos here and there. Other than mathematics and physics, I also do the medicine stuff. Okay, so thank you so much for joining me, and have a great time.